Oh, by the way, Gail, I'll get the telescopes out tomorrow night, and then Wednesday actually, I'll probably do a little thing about telescopes. Do you need to? Are you okay? Phones away, guys. Thanks. All right. So I won't ask you now, but I feel tempted after this little PowerPoint slide presentation to ask you which moon you would like to settle on, perhaps. Okay. I know it's hard to focus. I know because I've been through presentations. I'm like, are you serious? Are you done yet? But this is what you guys pay me to do, to try to kind of relay a few things to you. That might be on the test on next Monday. So, does Earth have a moon?
Yeah.
Does Mars have a moon?
Yes.
Yes. Does Mercury have a moon? No. Does Venus have a moon?
No.
Nope, Venus doesn't have a moon. Does Jupiter, Saturn, Uranus, Neptune have moons?
Mm-hmm.
Does Pluto have a moon?
Yeah.
So, this isn't necessarily in order. Actually, Jupiter, it is kind of in order. Jupiter is right after Mars. Jupiter is our first gas giant. Now, it's got more than 4 moons, but I'm going to kind of look at these moons individually. These are the 4 moons that Galileo saw. These are in order of closest moon to Jupiter outward. Io, Europa, Ganymede, and Callisto. These actually moons are, when we look through the telescope, did we see Jupiter the other day? I think we did. When you look at Jupiter through the telescope, these are the moons that you're seeing reflect light. Okay, sunlight. We have moons of Saturn, and I'd go ahead and kind of highlight. So these guys, you're going to want to know for the test. With regard to Saturn, and I'll narrow this down. I have a big moon here, Titan. The other one that's the big hit is Enceladus. That's hard to spell. Enceladus. That's associated with Saturn. Then we have Uranus. Let's see. Miranda is a cool one for Uranus. And then we have Neptune. And Triton is a cool one for Neptune. Oh, then we have Pluto. Pluto's big moon is Charon. Okay. Oh, Eris. Does anybody remember what we've heard Eris before? These are in order. So Eris is beyond Pluto.
Not like that other dwarf planet.
Right, it's another dwarf planet, exactly. Eris actually means like strife and stuff in Latin, I think. And so Eris, actually, the dude... Eris was responsible for getting Pluto demoted, basically, because they found Eris and they're like, oh, is that another planet? No, it's a dwarf planet. So very good. So here's a little bit about each of those 4 Galilean moons around Jupiter. Io actually has this yellow color, and that yellow color is related to sulfur compounds. And then we go to Europa. The next 3 moons that Galileo saw, Europa, Ganymede, and Callisto, they kind of have a crunchy, icy crust. Europa's pretty darn big. Ganymede is, I can't remember which one's the biggest. And then beyond Ganymede, we have Callisto. All of these, and it caught my eye as I was getting ready to do this lecture, they have synchronous rotation. What does synchronous rotation mean to our moon as it orbits the Earth? Remember? It's in sync. What's in sync?
How fast the Earth rotates compared to how fast the moon?
How fast the moon rotates, it's in sync with
how fast it goes around.
how fast it orbits, yeah. And so what does that mean? Do you remember what does the consequences it have with regard to what we see of the moon?
We only see one side of it.
We only see one side. So these 4 big moons of Jupiter have synchronous rotation, just like the Earth. So same side of the moon would be seen from the planet.
So I guess I kind of thought about this a little bit. Like, what if you're living on one of those moons? You just have a giant planet in your sky all the time. Unless, I guess you wouldn't be facing the sun if you lived on the side of the sun, but...
On the moons, you would still have daytime and nighttime because they spin, but it'd be different, wouldn't it? Yeah. But the moons would orbit the planet, yeah. And remember we talked about like Mercury, like now granted Mercury's a planet, not a moon, but Mercury you wouldn't see blue skies because there's really no atmosphere. And so that's kind of what you're running into with these moons too. Yeah. So here they are in all their glory. So this is Io, this is Europa, this is Ganymede, I'll put a 3 there, and this is Callisto, 4. I like this caption. So this is Io. This is the one that's kind of yellowish, and the yellow comes from sulfur and the compounds of sulfur. And Carl Sagan once said that it looks like this moon of Jupiter is in need of a lot of penicillin. Or a shot of penicillin. The word dynamic means that when we look at Io, we can look at it now and we look at it later, and the features have kind of changed. And actually, that's because Io has active volcanoes on it. So if Io, the little this is Io orbiting its planet, Jupiter. If Io has active volcanoes, then there has to be some sort of heating thing beneath Io's crust. And the heating thing is very similar to if you have a stress ball. I don't know if you've ever had a stress ball, and you kind of squeeze it, and it should get warm. Yeah. And what you're doing is you're taking the motion of the squeezing and you're actually heating it up, making the ball have more, the atoms that make up the ball have more kinetic energy. It's the same thing if you take a rubber band and go like this. That motion actually will make the rubber band heat up. So the thing about Io is you can see, I don't know if you can see it very good, but it's squished, it's kind of elongated towards the planet. So this is Io orbiting Jupiter. And so it's kind of stretched here, and it's stretched here, and it's stretched here, and it's stretched here. So it's very kind of similar to a rubber band, and it's that gives it the heat that makes it have this like spitting out sulfur containing compounds. Io. So I mentioned dynamics. So here's kind of looking at Io kind of spitting out material from under its crust. Io. And Io. Io. Okay. So we have Io, Europa, although this is Callisto. So this is actually what the moon looks like. And this is a close-up surface picture of the moon. I'm not thinking I want to live there. I'm gonna watch out. That doesn't look very good.
Why not?
Looks kind of dry and kind of scary. Yeah. This is Ganymede. And Ganymede has some features. This is one of the features of Ganymede. It's kind of got these tracks there. I like the captions. These figures that have this pretty rainbow came out of your OpenStax textbook. So it says that this came from Voyager 2. This one came from Voyager 2. Yes?
On this one, is it just me, or does it look like that's an Earth with no water? That's what it looks like.
Yeah, it
This
does.
kinda like
It's
a-
kind of got that.
It's like a dark green in the middle, and then at the edges and stuff, it's like a brownish color.
The green is kind of a false, but it does look green, but it's kind of more like a gray brown.
Yeah.
There's no, but it sure does look like the Earth there. Yeah.
And where is this a moon? You said
What's that?
this is a moon.
This is a moon that's going around the planet Jupiter.
Was this on one of the things like life could be on there or?
Yeah.
Yeah, that's very kind of.
But you mentioned life. This actually probably is more likely to have life. They all have kind of an icy crust, but this one, Europa, there's, there's more evidence that beneath the crust there's liquid water. So this is actually kind of showing you how the crust of Europa kind of broke apart over time at different times. And the caption actually says, you guys see where this is deeper tracks right here? That's more of a recent break, and it's over like these kind of more faded ones are old breaks. So you mentioned life. So the deal is those are, the crust can break apart. Underneath the crust is liquid water. Liquid water, people. That's pretty cool.
So if we drill a hole in the core, it's going to be water.
Europa. And so Europa is orbiting Jupiter, and another moon, Enceladus, is orbiting Saturn. And Enceladus is even cooler. than Europa. So there's Europa. Oh, Europa, Ganymede, Callisto. So, does Jupiter have more than 4 moons? Yes. I don't know the number. And they found
it's 67.
Is it 67? Okay, that sounds right.
I think it's 67.
That's a lot. And they found, didn't they find a few this summer? But there are other things that orbit Jupiter. Does Jupiter have rings?
Yeah. They all have it.
They all have rings. All the gas giants have rings. Exactly. So this isn't a ring, but here's Jupiter. Here's the planet Jupiter. By the way, Great Red Spot associated with the planet Jupiter. What's that?
How's it blue?
I just think it's kind of a fuzzy picture. It's not a very good picture, but it is Jupiter. And this is showing you where the moon Io orbits. And as Io orbits, it leaves like a trail of sulfur, kind of particle dust, kind of charged particles in its orbit. So they're looking like they're glowing here. But so that's caused by Io. All right, switching gears. That was Jupiter. This is Saturn. And I have 53 moons, but I don't know, maybe it's even more now. I didn't double check. Once upon a time it said 30, and I changed it to 53. But Saturn's got plenty of moons. One of its moons is called Titan. So take a look at Titan. Titan actually was landed on by a little spacecraft. So it had like an orbiter that sent down a spacecraft. They do that a lot. It's the orbiter is like the transport.
So, what's they call it? Scientists, they often drops a lot of spacecrafts along a lot of moons. So I would see why we would get attacked by
aliens.
Dropping stuff everywhere.
Yeah, I hear you. And actually, like Star Trek, one of their big things is do no harm. So, like, kind of like what you're saying, if we go ahead and put stuff out here, we could be harming aliens.
Yeah.
And we try to make sure our stuff is clean with regard to microbes and all that. So.
Our universe gonna fill up with all this spacecraft stuff.
Yeah, I hear you. Mars has really been has a lot of stuff.
Take somebody there so they can throw all this stuff away.
Yeah, I don't know.
It says that Saturn has 62 confirmed moons, of which 9 are waiting to be officially named.
62, so that would be 53. Yeah, 53 confirmed, but there are going to be 62. Thank you. Very good. So, Lily, did you have a question, or you just kind of double checking?
No, I was talking to her about the lab.
Okay.
She was confused on how it works. So.
Oh, okay. Yeah. Are you guys going to come to the lab?
I am. She has to work.
Oh, man. What time do you get off or whatever?
I usually don't get off until 9.
9?
It's in all of it.
Oh. That'd be like 9:30. You'd be there.
It usually always depends on
Traffic. No, it's claiming no traffic.
Traffic,
I'm
yes.
thinking I'm at home. I forgot.
Yeah, Nauvoo.
Yeah,
Deer, actually. Depends on deer.
Yeah, deer and flooding.
Yeah. Well, we can talk, but hopefully you'll have something else. And I am debating about looking for kind of a sort of an impromptu time when I can get the telescopes out again. So we'll see.
okay.
Yeah. Yep. So Titan orbits the planet Saturn, and we've landed on Titan. Titan was one of the ones that was in the video, and Titan actually has liquid, but it's not liquid water, it's liquid methane. So the formula, what's the formula for water?
H2O.
H2O. Yep. The formula for methane is CH4. That's methane. So it's so cool that actually methane is like cow farts, anyway. And methane is like methane gas we use to...
You said cow farts.
Cow farts. Yeah.
Cows farts?
Yep. And cows have a digestion sort of thing going on with all their stomachs and stuff. So honestly,
What?
With-
I never knew that.
several years ago, there was this whole thing about, and there still is about global warming, but methane is another gas that actually warms our atmosphere. And so there was like, hey, farmers, can you like make sure your cows don't pollute our atmosphere with methane? So, but I don't think that was.
So basically, make sure you don't feed your cows anything that make them fart.
Yes, but I think that's just metabolically speaking, that's impossible.
What?
Yep,
That's
because
wild.
their metabolism.
Crazy.
So yeah, so Titan has these liquid, this liquid here, but it's methane, and so they probably have like a cycle of, just like we have a rain cycle, they have a methane cycle where it rains methane. This is actually then the surface of Titan. Let's see, it was the Huygens lander. Huygens lander that actually roved the this little moon. So it kind of looks like Mars to me a little bit. Let's see if I can make it bigger. Doesn't it kind of look like Mars?
My teammates kind of judged me this weekend when we had I told them that I want to go to the moon as a dream vacation.
Uh-huh.
And they like, the moon? What's on the moon? I'm like, yeah, tripping.
Let's go.
Before this class, I would never said that. But now I think
Okay.
I want to go to the moon now.
Well, you have to keep us posted. You need to get lots of money, and then you can go to the moon.
I'm gonna go to the moon. If nothing happens and I find out some stuff that I wasn't supposed to find out about the outer space, then I probably won't go. But for the most part, I'm probably gonna go to some moon.
Make sure you give credit to Michelle.
Oh, of course. We
need to get her signature before.
Get on the moon and like record your like shout and snipes.
Yeah.
Right.
Flag and then freaking
Shut up, it's
food
nice.
pants and all that.
There's more Titan. All right. So I told you there's 2 E moons. Do you guys remember the E moon that was around? This is around Saturn. What was the one that began with the letter E around Jupiter? Europa. You're right, Europa. Enceladus orbits Saturn. Enceladus has these things called tiger stripes. They're down there. Don't they look like a tiger stripe?
Yeah.
And like this image says, it's like enhanced, so it's not really that blue. But like Enceladus, this is Enceladus. Like Europa, Enceladus actually has liquid water underneath it.
Is that what the blue is right there?
Yeah. It's not liquid water, but it's the kind of the cavity, kind of the trench that leads to the liquid water. So yeah. I'm going to show you a picture of actually seeing Enceladus with a little break in it, and it's shooting out material from underneath. Now, granted, when it shoots it out, it's not liquid because it's so cold. It shoots it out, it's basically snow. Okay. So this is Enceladus, kind of relative to the continent of let's see, Great Britain. To kind of show you how small Enceladus is. So can you see the little shooting out bits
Yeah,
there?
that's tight. What is that shooting out though? Is that that's coming from the core though, right?
That's coming from just under the crust. That's coming from under the crust. So basically there's a little break and it's shooting out. That is such a rush. This is taken by the spacecraft Cassini. I don't know if, excuse me, the word Cassini rings a bell, but he was a scientist a long time ago. With regard to the, what is Cassini, well, I'll go ahead and answer my own question. Saturn has rings, right? There's a major gap in the rings. There's 2 major gaps, but one of the gaps is called the Cassini division, okay? So that's kind of named after scientists. They named the spacecraft after that scientist. All right, so these also orbit Saturn. Mimas, check this out. The cool thing, what I think is cool about Mimas, it's got a humongous crater. Enceladus, we talked about, it's got the tiger stripes. That's kind of it for Saturn. Okay, switching gears. What's after Saturn? Actually, Uranus is after Saturn. We missed Uranus. We skipped Uranus, but Neptune has this Neptune has this moon called Titan. And one of the things that drives me nuts are things that sound alike, like terms that sound alike. And here are two moons that sound alike. We have Titan that orbits Neptune. What planet does Triton orbit? We just did it. First letter S.
Saturn.
Yeah, Triton is around Saturn and Titan is around Neptune. Okay, I know. Right? What's that?
You think it'd be the other way around, because isn't Triton also, because Neptune and Triton, aren't they both like gods or whatever?
Well, this isn't Neptune and Triton.
Sea.
Okay.
Like the green.
Yeah, I think Triton
Okay.
is a Greek god too.
Well, then maybe that's why Neptune has Triton. So yeah, and then Titan is with Saturn. So yeah,
Is Neptune?
Jupiter.
Wait.
I think so. I think Neptune is a god of the sea.
Triton. Yeah. Okay.
Ah.
I'm understanding now. I thought you were saying that Titan was with Neptune.
Nope, Titan is with Saturn.
And Triton is with Neptune.
Yep. Very good. So you've found a link to make Triton with Neptune.
I know that because of SpongeBob.
What's that?
SpongeBob.
Neptune.
Neptune and Triton, King Triton.
Yeah. Wow.
Who knew?
I thought the king of the sea was Jupiter though.
I think it's Neptune.
You're gonna have to search yourself because I like it. That's
So who in here likes the fruit cantaloupe? Cantaloupe?
you.
I love it.
Do you like the orange or the green or both? Orange. The orange. Okay. So cantaloupe. I don't know. Well, I guess that's honeydew, isn't it? Green. So does I don't know. Does this look like a cantaloupe to you? Kind of. I don't know. It's supposed to look like cantaloupe terrain.
For real?
Yeah. So it kind of has this two different
Like a
different
rock.
look here. Yeah.
The top texture does, but the bottom doesn't.
Right. The top. This looks like a cantaloupe, and I can't spell cantaloupe, so I'll just put can't. So Triton, not the cantaloupe region, but the other sort of kind of rougher region, it actually kind of has these geysers, kind of like we see on Io. And this is a better look. C actually calls it cantaloupe terrain. Here's a frozen lake on Triton. So what does it mean? We've run into the term retrograde a few times in here. Which planet is spinning backwards on its axis of rotation?
Jupiter.
No, it's not.
Venus.
It's Venus. Yes, it is Venus. It's spinning backwards. Why is it spinning backwards?
Because
It's
of
upside
the
down.
angle.
Because it's upside down. Why is it an angle? Because it got hit. Yep, you guys got it. You have a group test.
So I got A's, guys.
Good job, y'all. That's a good one. Would you do a group test?
Make my life easier. But no, can't do that. So that spin is called retrograde. And so where this is talking about that cantaloupe, the Triton moon, it says that actually it has retrograde motion. So here's the deal. Is this right? It is actually orbiting, we'll say counterclockwise, but it's spinning clockwise. So it's kind of strange. It is just really strange. Do you guys remember, is our moon, I'm switching gears to our planet, is our moon moving closer or moving away from Earth?
Moving away.
It is moving away, exactly. And so,
Why is it moving away again?
why is it moving away? It actually has to do with the fact that it's as it's spinning on its axis, it's spinning the same way that it's orbiting. So it kind of has like I call it torque, but it kind of has momentum to kind of be flung from our planet.
But what was you saying at the I forgot what it's called, because it grabs it back in. I don't want to say gravitation.
Gravity, yeah.
Y'all wouldn't get that.
Yeah, gravity's holding on to it, but it's losing it.
Less and less. So
Yeah.
we're gonna lose our moon in about like 100 years or something like that.
Oh, no longer than that. So I'm thinking that our sun is going to swell and basically,
So it's all in.
yes, suck us all in before we lose our moon.
What's so crazy is that I be thinking like this is gonna happen like 2 more years, so I get so depressed when you say this.
Well, kind of along those lines, has nothing to do with this class, but have you guys heard the recent UN climate
No,
thing?
no.
Is
Yeah,
we're
but
looking
it's-
at like 50 years or so for our climate to be drastically adversely affected.
What does that mean?
It means that there'll be a tipping point with regard to our atmosphere. That it's Venus. How hot is Venus?
Hot.
Yeah, Venus is very hot. Why is Venus so hot?
Because it's closer to
It's
the.
out. It's in it. It's outer, like the carbon.
It's not because it's closer.
Carbon.
Yeah. It's not because it's closer, it's because its atmosphere has got a bunch of carbon dioxide.
Oh yeah.
Yeah, yeah,
And
that's
so
why
it's a
Venus
bad
is so
smoke.
hot.
I mean, it's like yeah.
So actually the tipping point for Earth's atmosphere, not that we're going to become like Venus, but we kind of have that tendency for our atmosphere to, it's going to be hard to heal it, basically, with regard to
I'll be 70 though, so that'd be cool. I'll be and I'm trying to calculate
Yeah.
the year because
I
I'm
said
scared.
it's a tipping point. Yeah, the report
I
says
don't
it's a
like
tipping
this.
point.
Like, yeah, I
So
don't like that.
why wouldn't we become colder? We become hotter.
So yeah, we'll have more of the gases that basically trap the thermal energy with our planet. So
It's
I don't like
especially
the heat. I'd rather be cold.
Me too.
you know the thing about heat, you guys heard this too. Like not only is it just I gotta find a
we
fan,
can't breathe.
but well that too. But if you look, if this was the Earth, we look at the equator, we have all sorts of organisms, bacteria and things, fire ants that need warm temperatures. Well, if the warm temperatures aren't confined to the equator, warm temperatures are basically global speaking, then we have all sorts of migration of things that we didn't used to have
Ew.
up here at our latitude.
Ew.
Yeah, and so. Anyway.
So if that's with if the heat comes, or if it doesn't come.
If the heat comes,
We're gonna have like ant horses.
But it's going to be problematic because especially.
Wait, ant horses for real?
Yeah, they're gonna multiply. They're gonna be huge.
She said, for real?
I don't know if I heard
Yeah,
that.
No, there's gonna be all these animals we've never heard of before. They're gonna be.
Picture an ant horse.
Especially, and then cows gonna be really farting or something like that. Ew, I cannot.
It'll be a wild ride.
Like everything melts.
Hopefully, I already have my plan to like. It's either I'm gonna live out of space or have something built underground to where it can't fall unless, like, you know, the whole world fall type stuff. And nothing can get into. Have you ever saw not Back from the Future, but it's a movie. I think that movie is called Back from the Future.
I don't know.
He had him and his family. I mean, him and his wife built something down at the bottom of like probably under their house because their house got hit with a missile or something like that. And so they had food to like. He had food down there for his family for about.
I kind of remember that, and then they come back up, and it's
40
like,
years.
yeah.
The sun come back up and the sun come back up, like don't know nothing really, but he was smart.
Yeah, I kind of remember that. Yeah.
Yeah, that's one of I love that movie.
So we, good discussion. So that actually ends that part, and we're going to do a few slides here. All right. Kind of switching gears. What's that? So when we go look at the moon, how are we going to be able to see the moon? Does the moon have?
We got light bouncing off.
We got light bouncing off it from the sun. Exactly. Yes. And I'm going to try to kind of talk you through this, but the thing about light is, as awesome as it is only part of the energies that, like, the moon is sending us back. So we have a whole family of energies here that in astronomy we have to take advantage of because, I don't know, I'm probably not going to go to the moon. I might go to the moon, but we're kind of like earthbound, so we have to kind of tease that information coming from these objects, okay? So that's why it's so important. Guess what this object is?
The Earth.
No.
Not the Earth,
Not here.
Neptune.
not Neptune.
It's a moon.
It's the moon.
Nope,
It's not.
nope.
It's Jupiter.
It is a star. Which star?
The sun.
It is the sun, yes.
That was the sun.
It's a sun like you've never seen before.
No, never.
It's a sun. Have you guys ever heard of ultraviolet light? It's kind of a purple sort of color. Yeah. So actually, the abbreviation for ultraviolet light is UV. Okay. So I'm actually going to list 7. I call them cousins. 7 energies up here. So if we were, should you ever look at the sun with your eyes?
No. Why not? Try it.
Right. So this is actually looking at the sun with ultraviolet, looking at this particular energy that the sun's sending us. Do you think there's some cool information here? So when we study the sun, which is actually going to be in Unit 3, we're going to see that it has some kind of these holes, these kind of what we call conduits that actually kind of go through the sun in a sense. That looks like a hole. Okay. Up there, does it look like the sun's getting ready to spit something at? Hopefully the Earth's not in its path.
I got a question. So the sun flares, do it also like hit Earth any like time?
Yeah, they can.
So about like 2015, 2014, when we started having real hot summers, is that because the sun flares are?
Probably not. No, it's an element, but it what gives us our warm summers are more what's going on with the Earth's atmosphere than what the sun is doing.
Oh,
but it's a factor, but not the biggest factor.
So what do we get from those sun flares?
So we'll talk about that in Unit 3.
Oh, okay.
But that's a great question.
Oh.
Okay, so here we go. I'm going to write them on the board because actually remember you guys can bring a note card to your test. I'm going to be looking at your note cards that you bring to your test next Monday. I would make sure I get this down. So here's ultraviolet, abbreviated UV. And then on the other side of ultraviolet, have you ever heard of X-rays?
Yes.
I know you have. And then gamma rays. And as this turns out, this is the most energetic. I'll put E for energetic. Okay, and this is going to be the least energetic. So I need 7. So I need 3 more. So after light, have you ever heard of, what does IR stand for?
Infrared.
Infrared. And then we have microwaves.
What?
Yeah, so microwaves as in your ovens, your microwave ovens.
Yeah, I knew that.
That's one of the energies. And then we have radio. Okay, so this is the least energy. But these are all cousins, and they are generally called electromagnetic radiation. And so I'm going to go ahead and abbreviate EM, electromagnetic radiation. And when you hear me talk about cousins, oh goodness. Oh, I can't believe I just totally butchered that spelling. Cousins, this is the cousins I mean. These are the types of energies that are all related. They're family. And so this is important because in astronomy, when we start looking at pictures, like just a minute ago, we looked at a picture of the sun, and it was in ultraviolet energies. We can see different things. We look at stars and those different energies. All right, so what do these all have in common? Well, they're all forms of electromagnetic radiation. The different forms or cousins of electromagnetic radiation. They all travel at the speed of light. Okay, and speed of light is the variable c. Now, here's the deal. How do I say this? That's how fast they travel. That's their speed. Now, in a vacuum, is this a vacuum atmosphere? Like we're walking around here? Is this a vacuum? What do I mean by a vacuum?
Nothing new. I guess we bring
Nothing there.
Nothing.
Exactly, nothing there. So in a vacuum, you're looking at 3.0 times 10 to the 5th kilometers per second. So what does that mean? It means you count 1001, and it has gone 3.0 times 10 to the 5th kilometers. Is that pretty fast?
Yeah, that's pretty fast.
The thing, though, is that if you have anything other than a vacuum, it slows it down. Slows in stuff other than a vacuum. All right. So what else do they have in common? They travel at the speed of light. Also, like this slide says, They have little packet of energy. It's adorable. Like sometimes when I talk, it is adorable. When I talk about telescopes, I say that telescopes gather these little pieces of energy called photons. They are a piece of energy called photons. Little piece of energy. All right, what else? So we have these photons coming from the sun, or photons coming from the moon that first came from the sun, bounced off the moon. Little pieces of energy. The other thing about all of these 7 cousins, electromagnetic radiation cousins, is that they travel in waves. And this is a good way to think of a wave. Isn't that just an adorable, thing's adorable today, but a little frog. So what the frog did was it disturbed the water. The water is what we call the medium. And as it disturbed it, you had these peaks and these troughs, these peaks and these troughs. Notice they go out in all directions. Peak, trough, peak, trough, peak, trough. So light, I know it's kind of weird, but light as it travels has a peak, a trough, a peak, a trough. Light does, peak, a trough. Okay, radio waves have a peak, a trough, a peak, a trough. These all travel in waves.
The only difference is how often, I guess, you have a peak.
That's true. How often and then how far apart your peak and troughs are, exactly. So they all travel, they do this wave thing, exactly. Yep. I know it's weird to think it's got particulate and it's got waves. So over here you can kind of see the waves. And it's kind of like what Reed was saying, they do vary. Each of the cousins, I have 7 different types of radiation listed up there, but they're very different. Because for instance, if I was an astronaut and I'm in outer space and our sun decides to set off one of its flares, energetic-wise and all that, it actually, with that flare, it has some deadly radiation that my suit probably cannot protect me from. Okay? So the way this works is these are most energetic, most harmful to our cells. These are least energetic. The other thing I think about is like if you get out your little AM, FM radio or whatever and you're listening and all that, we have radio waves going through us. So I'm cool with that. So these, you can already kind of see, these waves are close together and these waves are far apart. So how do we talk about close together or far apart? That's actually what we call wavelength. So how are you going to know how long a repeating unit is? Well, you can either go, my favorite way is to go from a crest to a crest. So over here, I could pick this crest, and this distance right here is what we call the wavelength. The symbol for wavelength is the Greek letter lambda. And a lambda looks like a little, I've got it coming up here, I think.
It looks like an A with like a, I don't know, I guess like a top on it.
Yeah, it does. This is wavelength. This is wavelength. So that's a short wavelength, and this would be a long wavelength. Okay? Long wavelength, less energetic. Short wavelength, more energetic. Okay. So another thing I brought is this, if you buy sunglasses these days, most sunglasses you buy will say they're polarized. And the way polarized sunglasses work is, think of it this way. In the lens, they have kind of like a picket fence. It's weird, but it's like little lines. And so what that means is it helps with glare. What is glare? Well, glare is basically the sun's over there, and glare really comes oftentimes from choppy water. I think of choppy water. If you think of choppy water, you think of that water kind of poking up all these different angles. Well, the sun hits that, and we have all these different angles of light coming at our eyes. That causes glare. So what do these picket fences do? Well, basically, remember I said light looks like this? Basically, those picket fences only let in one direction of light. So if I have light coming from the pond that is going like this, I don't know, if it's going against my picket fence, it doesn't get into my eyes. It removes a lot just because of the picket fence. Well, if that's the case, then what if I have 2 picket fences? I've got 2, like sunglasses here. I have 2 picket fences that are going the same direction. all sorts of light coming through. What if I take those picket fences and make them perpendicular? So, okay, so these are like your sunglasses. Okay. By the way, this, I'll show you first and I'll tell you what, you might have seen this before. Okay, so the picket fences are going the same direction. Okay, so picket fences go in the same direction. Now I'm going to go ahead and take the top one and I'm going to rotate it. Okay, so now we have a picket fence going this way, picket fence going this way. And that can only work if light actually has a direction. It's directional.
When you were spinning it, like the circle behind you on the smartboard was changing colors.
Oh, is it changing colors?
Yeah, it went from like a dark color to a green and then back to a dark color.
Here you go, now. So,
These are the lenses.
yeah, those are polarized. Those are like, if you accidentally break your sunglasses, if you break your sunglasses, you can do the same thing. Here's the deal. Have you ever been looking at your smart device and then you're like, oh, you have your sunglasses on and you're like, dude, I can't see it. It's all kind of dim and funky. That's because that light is directional and it's like not doing well with your sunglasses. Let's see, what else did I bring? Oh, I'll check it. This actually, with IR, I'm going to go ahead and put heat.
And put both on.
Infrared radiation is heat, thermal energy. And just for kind of like a little demo thing. So notice it's no color.
Look at your fingers touching it though.
Yeah.
Oh yeah, that's what I'm going to show you.
It does heat on it.
Yeah. I'll pass this around too. So the deal, I mean, that's a good example of like, you're like, oh yeah, my hands, I see you because I see light bouncing off of my hands from the light in this room. That's all wonderful. But honestly, anything that has thermal energy has a heat signature. And that heat signature can tell a lot. So when we in astronomy look at objects, one of the things we sometimes look at is what is their heat signature. Oh, yeah, I think we are. I think we're going to have to quit there and pick up here in on Wednesday. So Wednesday, we're going to finish up this part and we're going to talk about telescopes. Now Wednesday, my PowerPoint on telescopes that I've uploaded to Canvas is pretty long. So actually I'm going to be kind of skipping through that a little bit. So be fine. We'll finish up Unit 2 on Wednesday. But hope to see you guys tomorrow.
Are we going to learn about telescopium?
Tell us that little constellation.
Yes.
It's hard to see.
Because we're learning about telescopes.
Right?
We'll learn about telescopes.
Telescopium's hard. Is that might be a modern constellation? I'm not sure. Stop.